Okay, so today we're talking about law of sines. It's a property that we're going to be using to figure out missing angles and missing side lengths for any triangle. It doesn't have to be necessarily a right triangle. That's the beauty of the law of sines. But for the warm-up, we're talking about finding area. So let's take a look at some of these examples. So area of a triangle is base times height divided by 2, or you might remember 1/2 base times height. So if we're looking at problem number 1 here, the base is 15, the height is 9, and then we divide our answer by 2. 15 times 9 is 135. Divide that by 2, and our area is 67.5. Normally we would put units on there, but there aren't any units associated with this, so I'm just going to put units squared, since we don't have meters or inches or anything else that we're talking about with this one. Problem number 2, very similar. Base times height, 10 times 13, divided by 2. 10 times 13 is 130. 130 divided by 2 is 65. And again, we'll just write it down as units squared, since there weren't any units associated with it. For problem number 3, I'm given the hypotenuse of the triangle and the base. I'm not given the height. So I need to be able to find this height. So we can say a squared plus b squared equals c squared. We can use Pythagorean theorem to find that third side length, which is 5 squared plus x squared equals 13 squared. Remember that the two legs are interchangeable. One of them could be a, one of them could be b, but the hypotenuse is always on the other side of the equal sign. So in this case, we get 25 plus x squared equals 169. Then we need to subtract 25 from both sides. I get x squared equals 144, x equals 12. So now, finally, I'm ready to find the area. I can say area equals 5 times 12 divided by 2. 5 times 12 is 60, divided by 2 is 30. 30 units squared. That's what problem number 3 is going to look like. Went through that kind of fast. If you need to, we can pause the video for a second. Otherwise, we're going to keep moving on. Okay, problem number 4, base times height. Again, we're going to need to use Pythagorean theorem. A squared plus b squared equals c squared to find that missing side length, because 30 is the hypotenuse. So I get 18 squared plus b squared equals 30 squared. 18 squared is 324. 30 squared is 900. Then I subtract 324 from both sides, and I get b squared is 576. And then I square root both sides, I get b equals 24. So the area of this triangle is 18 times 24 divided by 2. And I end up getting area as 216 units squared. For problems 5 and 6, now I'm dealing with rectangles and triangles. So what I'm going to want to do is I'm going to want to find the area of each one individually. So like if I do the area of the triangle, the base is 17 here. It's already given down here. And then the height is 5. So I do 17 times 5 divided by 2. And notice I write down area and then I put a little triangle below it. That's just to keep my shapes in line so I know which one's which. So first I find the area of the triangle, 42.5. I did 17 times 5 divided by 2. Then I'm going to find the area of the rectangle. We'll do that in a different color here. And we'll say area of the rectangle, that's just base times height, 8 times 17. And 8 times 17 equals 136. So I've got 42 feet squared, 136 feet squared. So I do 136 plus 42.5. And I get my final answer, 178.5 feet squared. That would be my total area. And then final problem here. I'm given two shapes again. I have a triangle and a rectangle. The triangle looks really weird here because I've got the hypotenuse of it is 25, but technically the base is going to be, or the height could be 15, and the base is going to be this green side here. So it looks kind of weird just because of the orientation of the triangle, but if I were to redraw it, it's a right triangle, and this might help you see it a little better. The hypotenuse of 25 and a height of 15, so we just need to find this missing side here. So same thing we did on problems 3 and 4. We'll start by using Pythagorean theorem to find the missing side of that triangle. A squared plus b squared equals c squared. 15 squared plus b squared equals 25 squared. And 25 squared is 625. 15 squared is 225. Subtract 225, I get b squared equals 400. And then I square root 400 and I get b equals 20, which I have represented by x here, but that'll be the side of the missing side length there. So now when I do area of the triangle, 15 times 20 divided by 2, and I get area of the triangle 150. Then I will do the area of the rectangle separately, and that's 19 times 25, and that gives me 475. So then I do 475 plus 150, just add my two areas together, and I get my final area of 625. Don't forget your units, inches squared. That's how I'm going to start this warm-up today. Okay, so moving on to the lesson today, the first thing I want you guys to do is we're going to continue to find area. So I have 3 different triangles here, except this time the height's not given to you. So in the first one we can see height there, second one height, and third one height. But what we need to do is we need to use trig functions to solve for the missing side length, and because the base is already given, it's 38.45 in this first example. But first find that missing side length. So for an example for the first one, I have a 72-degree angle right here. So I could say, hey, if I do sine of 72 degrees, I can think about this as opposite over hypotenuse, h over 21. And I can solve algebraically for the height, and then I can find the area of the triangle. And I'm going to round my answers to the nearest 100th, so 2 decimal places. So I want you guys to pause the video, take a couple minutes now, and work on these 3 triangles. All right, and then we'll pick up from there. So give it a shot now. Okay, so let's go ahead and look over these 3 problems. For the first one, we had it set up already for solving for h. So we have to multiply both sides by 21, and we get 21 times sine of 72 degrees equals h. We should get h equals 19.97. Make sure your calculator's in degree mode for that. And then we can find our area by doing base times height divided by 2. And remember to put the units on our area. So it came out to 383.92 centimeters squared. Okay. For the second example, very similar. We have the 55 degrees, and we can do sine of 55 equals h over 29. Multiply 29 by both sides to get h by itself. And then we can find our area that way. So the area should have been 392.04 centimeters squared. And then finally for the third one, this one's kind of a tough one because I have a 52-degree angle given and I have a 50-degree angle given. And the trick here is if I try to set up a sine ratio with the 50-degree angle, sine of 50, I would get h over, and I don't have anything here, so I can't set up the trig ratio properly with the 50 degrees. So that's why I chose the 52 degrees, because I can do sine of 52 is h over hypotenuse is 33.7. So being able to recognize where that hypotenuse is, where the opposite side is of the triangle, just making sure it's oriented, is really important as well. All right, so then I can multiply both sides here by 33.7 to get h by itself. And I should get h equals 26.56. And then finally my area formula, 26.56 times 43 divided by 2, and my final area is 571.04 centimeters squared. Okay, so for part 2 now, what I want you guys to do is to go ahead and think about setting up some trig ratios to solve for h for a general sense. So, for example, if I'm using angle A here to solve for h, how would I set that up with trig ratios? Or if I'm using angle B here to solve for h. So I could write two different equations. I'll do one in red and one in blue. So I want you guys to try and write up some trig ratios, thinking about using SOHCAHTOA for angle A and then SOHCAHTOA for angle B. So give that a shot now. Okay, so if you're stuck, then we'll show you what the first one's going to look like. It's going to be sine of A equals h over b, because that sine of A is opposite over hypotenuse of that small triangle. And then we want to solve for h respectively, so it's just very similar to what we did on the warm-up. We'll multiply, or not the warm-up, but on part 1. Multiply both sides by b, and we end up getting h equals b times sine of A. So now I want you guys to try that for part B, for angle B. Okay, so after you get angle B, you should have A times sine of B equals h. So what we've done is we've solved for h in two separate equations. And one thing we're allowed to do algebraically is we're allowed to say, hey, well, if h equals both of these things, then these two things could technically equal each other. And this is where this thing called the law of sines is going to come from, is from this idea right here. So what we can do is we can say, let's get all of the a's on one side, even though some of them are capital and some are lowercase. So we'll get sine of b equals b times sine of A over lowercase a. And then we're going to say, let's get all of the b's on one side of the equation. So we'll divide both sides by b. And we'll get this sine of b over lowercase b equals sine of A over lowercase a. And just an important thing to remember here about these things is whenever we find these letters, is whenever we have a capital A, which represents an angle, the lowercase a is going to be the side opposite of that angle. We'll see the same thing with B. Angle B is opposite the lowercase letter b, and angle C is opposite the lowercase letter c. That's going to be true every single time. And what happens here is now we've set up this ratio where we can say, hey, technically, in any triangle, doesn't have to be a right triangle, we can set up this ratio where we can say, hey, if you take sine of this angle B and then divide it by its opposite side, that should be equal to the sine of angle A divided by its opposite side. And if we actually worked it out again, we would find that sine of angle C also works. So this is going to work for all three sides here, where we can set up this same ratio. And that's going to help us find missing angles or missing sides for any triangle, not just right triangles. That's the key for this thing called the law of sines. We can use it for any triangle, not just right triangles. Yeah, so up until now, we've only been able to use right triangles, but from this point forward, we can solve for any triangle using this formula. So let me show you two things real quick here. First is we could write it like this. Sine of A over A equals sine of B over B equals sine of C over C. Second thing you could do is you could technically write it the opposite way, like A over sine of A. And you could write it as B over sine of B. And you could write it as C over sine of C. So you could do angles over sides or sides over angles. So go ahead and write that down real quick, and I'm going to explain why we're writing this down in just a second here. So for the first one, sine of A over A, This is going to be a better use of the formula for finding missing angles. And I'll show you examples why. So finding missing angle measures, we'll say. So go ahead and write that down. This will be good for your notes. Remember, we're allowed to have open notes on quizzes or on graded assignments. So make sure you have good notes. This opposite one where we have the sides on top, this is actually going to be better use for finding missing side lengths of a triangle. Okay, so the top one with the angles on top is better for finding the missing angle measures. The bottom one that I have shown with the side lengths on top is better for finding missing side lengths. Okay, that's going to be important for these particular problems. Okay. Oops, I'll give you a second to write that down. And let's go ahead and look at this now. So the law of sines does not work in every situation when solving for a missing side or angle of a non-right triangle, but it does work in a lot of specific situations. Okay, so here are two situations where the law of sines will work. Let's say situation number one, I give you triangle ABC, and situation number two, I'll just label it the exact same way. We can just do that right now. And we'll say situation number one, if I give you, let's say, a 25-degree angle, a 71-degree angle, I give you a side length of 30 centimeters, and then a side length of X centimeters. Okay, that's a situation where the law of sines is going to work. Okay, first thing, like when we're trying to solve triangles, and we have two angles in a triangle, we could find the third one. We don't need law of sines to do that. We could just find the third angle because we can say, hey, I know all angles of a triangle add up to 180 degrees. If I subtract 25 and I subtract 71, I'm gonna find that missing angle. And in this case, if I use my calculator, I end up getting 84 degrees. All right. Now, some important things to remember when we're doing these ratios. We want angle A corresponds to that X because that's side length X. Angle B corresponds to this side length, which we don't have any unit given. And angle C corresponds to this 30 here. So if I wanted to solve this situation number one, I would have to say, I want to use the one that measures side length specifically. I would say X over sine of 25 degrees equals 30 over sine of 71 degrees. So it turns out that 84 degrees was not useful for me in this particular problem, but we can always find the third angle measure if we know two of the other angle measures. But sometimes I might give you a side length that's over here, and then you'll have to say, oh, if I want to use the law of sines, I need to find that third angle measure first. So it's important to know that we can find that third angle measure. It's possible. Okay. Now, in order to solve for x, what I need to do is I need to multiply both sides by sine of 25. And I'll end up getting x by itself on one side equals 30 times sine of 25 degrees divided by sine of 71 degrees. Because I was using that formula, it's going to make it easy for us to get x by itself. And now I just can plug that into my calculator, and I'm going to get x is approximately 13.4 centimeters. So I'm just going to round to the nearest tenth for right now. If I had used the formula that's written up above, which said we're going to do sines on top, I did sine of 25 degrees divided by x equals sine of 71 degrees divided by 30. I can still solve for x, but it's going to be extra steps. And this is why I like having this method for solving the side lengths easier. Because the first step here is going to be cross multiply. I would have to say multiply 30 by the left side, get 30 times sine of 25, and then multiply x by the right side, and I get x times sine of 71. So here's the first step. And then the second step is going to be divide both sides by sine of 71. And then we end up with 30 times sine of 25 degrees over sine of 71 degrees. Sorry, I can keep parentheses on these. And that equals x. So notice that I finished in the exact same spot here, but it took me a couple steps longer. So you can definitely do it either way, but it's going to save you a step if you use the method that I showed you. All right, so if you use the sides over the angles instead, it saves you that step. All right, that's example number 1, or situation number 1. If we need to pause the video for a second, we can. Otherwise, I'll move on to situation number 2. Second situation here, if I'm given information, like let's say I'll give you this angle, 67 degrees, side length 62 centimeters, side length 58 centimeters, and then I'll give you x degrees here. So this time we want to solve for an angle measure instead of a side length. And we see x corresponds to the 62 centimeters. So we'll say sine of x degrees over 62 equals, we'll do the other side, sine of 67 degrees over 58. Those are the ratios we always want to set up to get our trig functions by themselves, or to get to solve for a missing angle or missing side length, I mean. Okay, so now I can multiply both sides by 62, and I'll get sine of x degrees equals 62 times sine of 67 divided by 58. And I can just put that into my calculator, and I'll get some weird number. Turns out here it's going to be like 0.98. Now, I need to get x by itself, so I have to undo a sine. And we talked about this last time. We would do the inverse of it. We talked about it last week. We're going to do sine inverse of both sides. That's how you undo a sine. So it's like sine inverse of x equals sine inverse of 0.98. That's the inverse operation. And we'll end up with just x degrees equals sine inverse of 0.98. And remember to put that into your calculator. You're going to need a calculator that can do this. So I find the sine inverse button above my sine button on a lot of calculators where I just have to hit the second button. And I should end up getting approximately 78.5 degrees for my angle x. That's how I would do inverses for these particular problems. Okay, so we have 3 problems down below now that I want you guys to practice on. And we're solving for the entire triangle. That means we're finding all missing side lengths and all missing angles. So I'm going to give you guys a few minutes. Go ahead and pause the video now, work on these 3 problems, and then I'll show you the answers in a minute. Okay, so now, let me give you a second. For problem A here, what we want to do is, or for problem 1 I should say, we want to find missing side length A, measure of angle C, and side length C. So the absolute first thing you can do if you have 2 angles, find the third one. Pretty easy, just do 180 minus. And we end up getting 66 degrees here. That was our answer for the first part. Then for finding the side lengths, one thing to keep in mind is that 85 degrees happens to be the largest angle, and the longest side is always going to be opposite the largest angle. So angle C, or side length C, should be shorter than that, and side length A should be the shortest since it's the smallest angle is opposite of it. So when we find side length A, we end up getting 4.4, and that means that side length C should be between 9 and 4.4, and it is, which is a good thing. So that's just how we can verify our answers there. but we're just doing that simple law of sine setup and then solving for the respective variable. Okay, that's the idea. So now try the other two, give you a minute. Okay, for the last two problems then, problem 2, I got the measure of angle A is 29 degrees, just 180 minus, and then I have to find side lengths B and C using law of sines. So there's my work for that. I have it in purple and orange respectively. And then finally for problem C, this time I'm only given one angle, so I have to find another missing angle. The one I have to start with is angle C because I don't have any information for B. I don't have angle B or side length B. So I find angle C, I have to do the inverse sine thing to get C equals 47.2 degrees. But then I can find the measure of angle B pretty easily by doing 180 minus, and I get 81.8. And then finally I can set up another trig ratio to solve for side length B. So that's what's going on with example C there, or part C3 there. Okay, so your assignment tonight is practicing 9 law of sines problems. Just round everything to the nearest tenth, any decimal answer. All right, best of luck to you. I'll see you guys tomorrow.